Sorry. Where's my pen? Oh, come on. Oh, here we go. Sorry. I need a calculator, and here we go. Alright, this one is due tomorrow, so sorry I didn't make a video earlier. Alright, Craig went bowling. $25 to spend. Okay. He rented shoes for $5.25 and paid $4 each for each game. What's the greatest number of games Craig could have played? Well, right, so inequalities. So it has to be less or equal to 25. He can't spend any more than that. The shoes is a one-time payment, right? So you only pay that once. Plus $4 per game. That's the inequality that you're looking at. Well, let's solve it. Minus 5.25 over here. Minus 5.25 over here. That goes away. 4 times g comes down. Less or equal to 19.75. Let's divide 1975 divided by 4. So we're going to divide both by 4 on each side. And the number of games he can play has to be less or equal to 4.93. So can he play 5 games? No. So that's obviously if he can't play 5, he can't play 6, he can't play 7. Well, the greatest number of complete games, I guess, would be 4. So this whole section is inequalities, all right? Just good to know. All right, well, that's good. 2. Ben earns $9 per hour, $6 for each delivery he makes. He wants to earn more than 155. So right away I can set up like this, right? More than 155. Okay, so it can't be equal to 155, it has to be more. In an 8-hour workday, what is the least number of deliveries he must make to reach his goal? So if he works now 8 hours, so he's going to get $9 per hour, right? So 9 times 8, so he's going to make $72. $72 he makes guaranteed, plus $6 for every delivery. Let's call that D. So how many deliveries does he need to make in order, right? Because he already has banked $72. So he needs to make a certain amount of deliveries because every delivery he gets $6 to reach that goal of 155. So just like the previous problems, minus 172, minus 72. So the hard part is setting it up, right? Because the solving part, it's pretty easy. And you get 83. You divide this by 6, divide this by 6, and the number of deliveries divided by 6 is 13.83. So he has to make 13.83s in order to reach his goal, but you can't make 13.83 deliveries. He has to make, in this case, 14. He wants to ride his bicycle more than 80 miles this week. So again, you can start setting your inequalities. She already has ridden 18 miles. So right off the bat, I mean, I guess maybe I'm jumping the gun. These two are garbage because it says less than 80 and less than 80, right? So you don't have to worry about A and B. So more than 80, more than 80. And she already has biked 18 miles. And it would be plus 6 days times however many miles she does per day. So it looks something like that. And the only one that looks like that is this one. 4. Trailer used to transport several 40-kilogram crates to a store, so there's boxes. The greatest amount of weight that can be loaded on a trailer is 1,050. An 82-kilogram crate has already been loaded on the trailer. What is the greatest number? So you have a truck that can take this many, right? So that's what that says. That's the maximum weight that can go on the truck. You already have this much in the truck. So how many of these can you fit in? Well, it has to be the greatest amount that the truck can take is this. So it has to be less or equal to 1,050 kilograms. So whatever you put in that truck has to weigh 1,050 or less. You already have 82 kilograms in there. So that plus however many of these, how many 40-kilogram boxes can you give? So 40, well, they use the word crate, so 40C. Well, minus 82, minus 82. So we have 40C less or equal to minus 82 equals 968. And I divide both sides by 40. The greatest number of crates is 24.2. You can't go above 24.2 crates. So obviously we can't have 24.2 crates, so we're gonna write that the greatest number is 24. 5. Winston needs 80 signatures from students in his school before he can run for class president. He already has 23. So again, he needs at least 80, right? Means 80 or more, right? So it has to be 80 or more. So the only one that says 80 or more, and then just looking at these multiple choices, it's this one. That says greater or equal to 80. This doesn't make any sense, and this doesn't make any sense. This doesn't make any. I didn't even read the rest. Well, let's read the rest. He already has 23 signatures already. Here it is. He and 2 friends are going to get the remaining signatures at lunch. Everybody gets the same amount of signatures, so which inequality can Winston use to determine the minimum number of signatures each person should get? So there we go here. 3 times, and everybody gets a certain amount of signatures, plus the 23 that they already have, has to be greater or equal to 80. So this question, seriously, just by looking at multiple choice and understanding this part here, it's pretty simple. So you don't, again, use the multiple choice to your advantage. Right? 5, Yolanda participating in the walkathon. Each kilometer gets $10 for charity. Her goal was to raise more than 300. She raised 50 on Sunday, so she wants to go more than 300. She already has 50, so let me put that. And then, how many distances in kilometer should Yolanda walk on Sunday to reach her goal? Well, so how much does she get per kilometer? $10 per kilometer, right? So that's how many kilometers that she has to walk on Sunday to reach her goal plus of greater than 300. So 50 is 50. 10K greater than 250. Divide by 10, divide by 10. The number of kilometers she has to run is greater than 25. So A doesn't make any sense because that's greater than 5. No, greater than 25 right here. Right? This is a little open, right? And it's pointing to the right. Greater than 30 is not it, and greater than 35 is not it. So it's here, greater than 25. Josh has a reward cards from movie theater. He receives 15 points for becoming a member, 3.5 points for each visit. He needs at least 55 points. So he needs, whatever he's collecting here has to be greater than 55 or equal to 55. He already has 15, and then he gets 3.5 per visit. So which inequality can Josh use to determine X, the number of visits? So there you go. So this look like anything. So what they have here is they have the 55 on the other side. So that's okay. So if you put 55 on the other side and 15 plus 3.v on this side, the only thing you have to do is make sure you change the sign. Now do we have anything that like that? Yeah, we do. There we go. Right, so it's okay to switch sides, right? Remember that I told you when we were doing inequalities that I'm the type of person that likes my variables on the left, right, and my constant on the right. So this one, it's just the opposite. If you switch side with any inequality, right, even when you're solving, so let's say inequality 2x plus 10 less than 5, right, and you solve this, and you like the 2x, the variables on the right side, it's okay, you can switch sides. But make sure you switch the inequality. It keeps it the same. Now with an equation, likewise, 5x plus 6 equals 40. Right? I'm completely fine with this, but some of you want to switch sides. But in the equation, there's nothing to, you don't have to, it's equal, right? So switching sides, they're both equal to each other, doesn't make a difference. But in equality, if you want to switch sides, you got to make sure you switch the sign as well. Okay, so the answer is C. 8. Manny goes bowling. He has $25 to spend. So whatever he spends has to be less or equal to 25. $4.25 to rent shoes, and then plus $2.50 for each of the games. That's your inequality. So how many games can he play? Well, let's look at this. So this obviously won't be garbage because it says greater or equal to 25. This is also garbage. And these two would be what you would have to worry about. Well, $4.25 is your constant because that's a one-time payment. $2.50 per game. So here it is. $2.50 per game, right? $4.25 is your shoes that you only pay once, and then $2.5 is multiplied by the number of games that you play. Okay. 9. Baseball team order hats. Each hat's $9.95. The shipping charge is $5. There is no tax. The total cost of the order is less than $125, which inequality can be used to determine the greatest number of hats. So less than 25, not this, not this. So it's either B or D. Now, H stands for the number of hats. The number of hats is multiplied by what? 995. So here, the number of hats is multiplied by 5, but that doesn't make sense because 5 is the shipping charge, right? So if you understand the problem, you know that the number of number of hats has to be obviously multiplied by 995 because that's the price per hat. And here, and that 5 is the shipping charge. So correct answer. Caitlin wants to buy a $75 skateboard. She has $25 saved so far. She mows lawn to make extra money and earns $20 for each lawn, which inequality can be used to determine the number of lawns so that she needs to mow. Well, so she needs to make $75 or more. So this is garbage because it says less than 25. Sorry, less or equal to 75. No. Has to be greater or equal to 75. So this one is garbage. So B or D would be your correct answer. So 25 is your constant because that's what she has. So she has 25 plus $20 times however many lawns she mows. That all has to be greater or equal to 75. And where's the answer? Here it is. B. 11. Harper has $15 to spend at the grocery store. So again, keeping with the topic of inequality, we know that it's going to look like this. It can't be over 15, so it has to be less or equal to 15. She's going to buy bags of fruits that cost $4.75 each and one box of crackers. So the one box of crackers is this. That's it. It's just one box. Plus bags of fruit, so more than one bag. So each bag is $4.75. So we don't know how many bags she's going to buy yet. So let's put it like that. $4.75. So here's the one box of crackers, and then $4.75 times however many bags. So they're wondering, the question is, how many bags can you buy? So think about it. You go to a supermarket, you have $15. Well, you buy a bag of crackers. So let's subtract $3.50. And you're left over with $11.50. So now, the $11.50, how many bags of fruit of $4.75 can you buy with $11.50? Well, just doing it like this, right? You know that the answer is going to be 2, I believe, maximum bags. So let's do it minus $3.50, and it says show your work, so minus $3.50 on both sides. That goes away. 4.75 comes down times B, less or equal to $11.50. Divide this by 475, divide this by 475. So B, the number of bags, will be less or equal to 1150 divided by 4.75, 2.42. So she can buy 2.42 bags or less, but we can't buy 0.42 bags, so 2. Okay, so Jim needs a car. The rental car charges $20 per day, $21 per day, and 10 cents for every mile driven. He will travel 250 miles. He has $115 to spend. What's the maximum number of days that he can rent a car? Well, so it has to be less or equal to 115, whatever he spends. Travels 250 miles, so I know how much he's going to be charged for that. So if you take 250 times 0.10, right? We know that just the miles itself, the company's going to charge him $25 for all the 250 miles that he's going to drive, plus $21 per day. $21 per day. There you go. So how many days can he rent a car for? So think about this. You have $150. You know that you're going to drive 250 miles. Each mile is 10 cents. So just for driving 250 miles, they're going to charge you, you're going to spend $25. There you go. Subtract. So now you have $90 left. Now with $90 left, they're telling you that every day that you rent a car is $21. So how many days can you rent a car if you have $90 left? And you know that each day is 21. This is what that inequality says. Right, so let's subtract 25 from each side. We get 21D, that goes away, right? 21D less or equal to 90, right? It's exactly what I have here. Now we're going to divide both sides by 21, and D is less or equal, 90 divided by 21. He can rent a car for 4.28 days. So he says the maximum days he can rent is 5. No, he can't. It's too much. He doesn't have money for 5 days. He has money for a maximum of 4.28 days, or just, I guess if they're going by days, the maximum he can rent is for 4 days. And that's what you would write. I think we use this question for a test. Cell-phone plan pays $30 per month. That's not bad. 5 cents per text. She wants to keep her bill under 60. Okay, which inequality represents the number of texts that she can send each month while still staying for her budget? So, whatever she spends on her phone company has to be less than 60. Not equal to 60, because it says right here, under 60. The cell phone plan is $30, so she's going to pay $30 a month, plus 5 cents per text. So how many texts is she allowed to send? So think about it. $60, take away the monthly bill, monthly charge is $30, so you're left with $30. How many texts can you send? Can you send with $30, knowing that each text is 5 cents? Right? So show the process. Minus 30. That goes away. 0.05t less than 30. We're going to divide both sides. T. Divide both sides by 0.05. So 30 divided by 0.05, and the number of text has to be less than 600. And here we go. All right, good. I'm glad we did this inequality thing. It's been a while.